This is a quick review on Unit 4. You want to make sure that for Unit 4 you have read all the lesson, taken notes, and looked through your notes. And then this is just a quick review on the most important things that you definitely want to make sure that you know, the key points. And I'm just going to go through some of those. So in Unit 4, here are a few of the things that you have learned in this unit. The center of the Earth, you want to make sure that you know all the layers that make up Earth and what they're made up like, what their composition is. We looked at continental drift. You want to make sure that you're really familiar with that concept. Alfred Wegener is the guy who came up with the theory of continental drift. You want to make sure to keep that separate from seafloor spreading. Seafloor spreading is our evidence of plate tectonics, and continental drift is just the theory saying that the continents have drifted apart over time, and Alfred Wegener had 4 pieces of evidence to support his theory. So you want to make sure that you know what those 4 pieces of evidence are, and then you want to make sure you keep that, again, separate from seafloor spreading and plate tectonics. You looked at energy of convection, so how convection is moving through the mantle to make those plates move and spread apart or run into one another or slide past one another. And then plate boundaries, and this is where we're going to spend a majority of our time, is looking at those different boundaries and what's happening within those boundaries. You also looked at landforms, so what kind of landforms are created. We're going to review that when the boundaries do different things. And then you looked at earthquakes and seismographs and how scientists use those seismographs to look at earthquakes. So that's just a quick overview of what you did in this unit. Again, you want to make sure that you're taking notes as you go through your lessons, and those notes will really help you on these unit assessments. So right now what we want to do is we just want to go through what is happening at each of those plate boundaries. So again, I mentioned that you want to make sure you know the structure of the Earth. You want to make sure that you know we've got this thin crust, then we have the mantle, the outer core, and the inner core. The inner core is solid. The outer core is liquid, the mantle is like plastic, and then the crust is solid. You want to make sure that you know that. So right now, if you are watching this review, you want to make sure that you're taking notes again and adding those to your science notebook. So I would write down each of these layers and what they're made up like. Now we want to talk about those boundaries and what's happening at each of those boundaries. So the first thing that you need to know is you need to know that there are 2 different types of crust on the Earth. The Earth is made up of continental crust, which is thick and buoyant, meaning that it's less dense than our oceanic crust. The oceanic crust is thinner, but it's more dense. So it's really heavily compacted together, and it's going to be heavier basically than our continental crust because it is more compacted and dense. So there's our 2 types of crust, continental and oceanic. So depending on what types of crust are doing the action, different things are going to happen. So let's take a look at those different boundaries and what's going on. So we have our convection cells within the mantle. As those convection cells are moving, they're moving our plates. So 2 different forces are in action making our plates move. We've got convection cells within the mantle moving them, and then we have gravity pulling these plates down. So subduction is when one plate moves under another, and so both convection and gravity are the forces at work making these plates move. Convection is the main force, and then when a plate is subducted, gravity is going to help pull that plate down. So we have 3 different types of plate boundaries. We have divergent, that's when our plate is moving apart, convergent when it's moving together, and transform when they're sliding past one another. So let's take a look at our divergent boundaries too. First, if you have 2 oceanic plates moving away from one another, you would think that you would have a big gaping hole in the Earth, but that is definitely not the case. So here's our convection cells moving these away from one another. You can see these arrows where they're moving away. You have new material coming up through that gap and hardening to make a ridge. So at a divergent plate between two oceanic crusts, you are going to have a ridge. The big mid-oceanic ridge is one example of that. So you're going to have a ridge. When you have a divergent boundary between two continental crusts, very much the same thing is going to happen. You've got these two plates moving away from one another, but now instead of your oceanic crust, you have two pieces of continental crust moving away from one another. Still, that new material is coming up through the middle. Iceland has a divergent plate boundary running through its middle, and what you have in the middle of Iceland is an example of continental rifting. So when this is happening in between two continental crusts, it is called rifting. So with a divergent boundary, you're either going to have a ridge, which occurs in our oceans, or a rift occurring. Now let's look at our convergent boundaries. That's when two plates are running into one another. And so you're going to have different things happening when you have continental crusts colliding, when you have oceanic crusts colliding, and when you have one of each, continent and oceanic crust collisions. You want to make sure that you take note of what happens at each one of these collisions. So let's take a look first at our two continental crusts colliding together. When you have two big thick crusts colliding into one another, they're going to push into one another, and one is going to fold up and create a mountain range. Examples of that would be the European Alps, the Himalayas, very large mountain ranges created through two continental crusts colliding with one another. Now eventually one of these crusts will slide and subduct under the other. And anytime you have a plate subducting, you're going to have it will begin to melt, but it will also begin to create friction with the lithosphere here, and you're going to have some deep focus earthquakes. The main thing that's going on between your two continental crust collision is the mountain range forming. And then a secondary thing would be you've got some earthquakes going on where the plate is subducting, but the main thing is those mountains forming. So there's some examples of the mountains forming. All right, then between our continental and oceanic collisions, that oceanic crust is thinner and more dense. It will always subduct or go underneath your continental crust. As it's subducting, gravity's pulling it down. This is going to begin to get hotter and hotter until it melts. When it melts, that new material is going to rise up between our continental crust, and we're going to have a volcanic mountain range forming. So at a continent oceanic crust, we have a volcanic mountain range forming. So there is examples of that. When we have two oceanic plates colliding, now we have, again, one of the oceanic crusts will eventually subduct under the other. This is where we have a trench form. A lot of people think a trench is formed by a divergent boundary, but remember our divergent boundary, we have new material coming up between that crust. So what's happening here is where this plate is subducting under the other one, you have a large trench forming. These can be very deep trenches, such as the Mariana Trench, which is 11 kilometers deep. So you're going to have a trench form, and then again, where you have this subducting plate, it's going to melt. New material is going to rise up, and now you've got, again, volcanoes being formed. But this time, see, in our last one, we had a continental crust over here, so we had a big continent over here. That's why we had a mountain range forming. Now, because it's two oceanic plates, this is in the middle of the ocean, we aren't going to have a mountain range forming. Instead, we're going to have an island forming. So that's where we get our island arcs. And then our last type of boundary is our transform boundary. And this is where two plates slide past one another, and their friction is going to cause a lot of earthquakes. Such as the San Andreas Fault, you have a lot of earthquakes occurring on that boundary. All right, so that is just a brief overview of what you've got going on between each of those plate boundaries. That's the thing that stumps students most, is what's going on with each of those plate boundaries. So make sure you've taken good notes on that. Here is just another picture to show you kind of what's going on. Here we have a divergent boundary with that new material coming up in the middle. When our plates subduct, remember I said there can be earthquakes going on where the friction's occurring underneath. These would be deep focus earthquakes. And then this is just a better picture of our convergent boundary between two oceanic plates where we have a big trench forming. Where that one plate is subducting, that's where we have our trench forming. And then we have an island arc because this plate is subducting, melting, and rising up. So there's our island arc. So that was just kind of a better picture of that I wanted to show you. So please make sure that you've got notes, that you review those notes. And if you have any questions on what's going on in plate tectonics, just let me know. Thanks.